Welcome, everybody, to the session on ML optimizations and strategy for a post-COVID era. I will be introducing our lovely speaker here. Sharmistha Chatterjee is a data science evangelist with 15 plus years of professional experience in machine learning and cloud applications. She's currently working as a senior manager of data sciences at Publicis Sapient, where she leads the digital transformation of clients across industry verticals. She's an international speaker, 2 times Google Developer Expert, HackerNoon Tech Award winner for 2020, selected as 40 under 40 data scientist by AIM, and listed as 21 Tech Trailblazers 2021 by Google. So without further ado, I'll let Sharmistha take it away.
Thanks for the very nice introduction. So let's get started with machine learning optimizations and strategies for post-COVID era. So what is the agenda for today? Today, first, we will see what is machine learning and why we are taking the subject like pre-COVID or post-COVID world. Has anything changed? Then we introduce the concept of concept drift in machine learning models. Then we talk about strategies for drift detection and mitigation. We'll look around best practices, be it business or technical, for ML risk management. We'll see some of the impacts and solutions to different industries, followed by an appendix, which we have listed some of the data sets which you could use or solutions you may look at. Now let's see what are the key takeaways when you go back. How do you apply the learnings that you had today? First of all, you will look around the consumer behavior, how it has changed due to COVID. We'll see some real examples. Then we will learn about how do we detect the drift in post-COVID-led strategic businesses for different industry verticals, be it supply chain, be it automobile. Then the ultimate aim is to go back and build resilient machine learning models by applying concept drift in the models that are very much dynamic in nature. So you can refer to some of the links which are referred in the presentation, or you can Google around. Many links are available, and you can contact me on LinkedIn or Twitter, or message me after the talk is over with your questions. So let's get started with machine learning in COVID and post-COVID world. As you can see on the left-hand side of the figure, the entire digital strategy has changed due to COVID. People are more relying on online games, online mechanism of telemedicine, teleconsulting, online learning, and video conferencing and video chat. People are not going to the markets. And this is not noticed in one country, but it has been the same for France, Germany, Italy, Spain, UK. Everywhere you see there's more digital adoption, more online streaming, and in restaurant delivery, there has been an upsurge in customer requests. So they get and they pick up through the curbside pickup, and even these customers are also sometimes the first-time customers who have never used digital mode of communication, be it grocery or be it in a retail shop, any kind of retail shop. And this behavior in compared to retail, we see a drastic change in travel industry, where compared to 2020, where compared to 2019, 2020 sees a significant dip in the number of international passengers as well as flights. Why? Because people are not going out. There has been an entire stoppage on international flights. There were very few flights flying around. And then we see again a similar kind of behavior change in online shopping. Why we chose this? If you see that what customers are searching in Amazon, if we try to look at the first 10 search terms, we will find that customers are looking around face mask, hand sanitizer, disinfectants. And this may be and the rate that they are looking at is maybe exponential in case of Italy, which we have known that Italy was one of the most affected countries initially. But it may be a little bit slower in Mexico. But the trend remains the same. People are not looking around fashion items, or they're not buying furniture in online mode. Whether they are looking at these items, and this leads a total shift in the paradigm of supply chain or inventory change, customer preference change, as well as regional change and trends. Now, with the consumer change, what we have to see is what's the journey in the industries during COVID? What are the causes? So we talk about causes. First and foremost, we will come across human behavior, the economic activities that are going on in the current city or country, which they are from where they are purchasing the items, the lockdown, the self-isolation or social distancing rules. And this has reduced the number of in-store shopping or a significant increase in online shopping. There has been a change in purchase items, as we have seen for airline industry. And when we see this change, it is not only the duty of data scientists or data engineers to come forward and handle those changes, but it is a bottom to top approach like this. Once they understand the change, this has to be supported by data architects, ML management, as well as the C-level leadership to handle those changes, so that at the end of the day, we are able to increase the customer engagement. And when we talk about customer engagement, we see their convenience, their safety, so that they are at home, but still they can buy the items which they are looking for, and how quickly we can deliver them, so they are happy. Now, if we talk about machine learning model, what it does, so we get some data, we apply the model, and then we get the output. You can see here. So the output, there is something happening before COVID or after COVID or during the COVID. That is, the output is having some change that we are going to look at. So since the data is changing, because the behavior changed, the input environmental conditions change, the ML models are also having a change in their outputs. And where are those changes? The model outcome changes. Of course, it can be a probabilistic outcome, or it can be a 0-1 binary outcome. And this outcome is a reflect of the change of the input data, the behavior, customer behavior from a single source, or there could be multiple sources. The unit may change. If you see, sometimes we do a temperature analysis in centigrade, sometimes in Fahrenheit, and some of the data fields may change. There could be new features coming in. There could be entirely old features which we need to be dropped. So are we always looking at these models and understanding what we are, that these features are necessary for the model outcome? And when we talk about change, the data statistical properties change, the input variables change. And when this change happen, and down the pipeline in the workflow that we would see in MLOps, right, the upstream data change is also is causing also not only the output change, but the output behavior or the statistical properties of the target variable is also changing because of this. And that's why we talk about drift. And let's see, how do we define drift? So in machine learning model, there could be a significant dip or a significant increase in the outcome, like the outcome, or which we call the target variable. Here in the left hand side, you can see that there's concept drift in an automation process or a product delivery, where there has not been any adaptation or dynamic process or workflow in terms of MLOps. And the drift detector, if we have a sufficient drift detector, all the algorithms in place, and the end-to-end production pipeline in place, it can significantly boost the accuracy to 69.38%. Whereas without the drift detector, what will happen? It's only 54%. Same with online news recommendation model, where if we apply concept drift, the adaptation, the dynamicity of the machine learning model can boost the accuracy to significantly to higher than 60 or 70%. Even a 90% you can record, not even 90%, 85% to 90% you can see. But without the drift detector, your accuracy drops below 40%. So you can understand now how important it is to detect the drifts. And how do we do that? We will see. So not only this, you have seen in continuous data or discrete data, but also in textual data, sentiment analysis, just talk about. As you see in these two diagrams, the fast text detector as well as the BERT model, which has been trained with 2018's data. That started to drift around 2019. Slowly, the slow drift has started. Now, it has picked up during the pandemic times. So say 2020, February, the dip is significant. It has the drift or the dip in performance has been significant in both the models. What we see, that vaccine sentiment index has dropped from an average of 70 to 30% in case of FastText, where in compared to like droppage from 50% to 15% in case of BERT during the start of pandemic. People are looking for vaccinations because the disease is spreading, but they're not able to get it. So there is a negative sentiment. And when we see that there is a dip in model accuracy, then how do we define the model outcome? In terms of the input data, we have talked about input data, model, and the output. So input data, if you have two variables A and B, and there is a straight line, that's the decision, that is the data decision boundary, that can stay constant or that can change. And consequently, our model outcome may change or may remain stationary. Now, there are two terms. It can remain stationary or it can change. So if you see at a time T1, this is my data decision boundary. At the time T2, it has changed. The data decision boundary has changed. And consequently, the modern decision boundary has also changed. This is a drift. And if you try to analyze for a long term means in a live production system which is running for hours, you will see that there are fluctuations. The model is performing bad. Maybe you have applied retraining, relabeling the data. If you are adaptive, you boost the accuracy, you boost the F1 score. But again, if you're not vigilant, it dips. Again, you are active, you retrain the data, relabel it, the accuracy increases. So how can we manage such models? Can we do that in manually, like doing every time diff is detected, some DevOps goes and changes it? No. We have to know all the terms of diffs and how we can mitigate those. So you can see, like, there is a two concept. There's a virtual drift concept and there's a real drift. So the real drift is like the data decision boundary changes and the model decision boundary is also changing. So probability of X changes and probability of Y, given the X has changed, the data has changed, is also changing. So here you see this concept model. This may not be a proper example of a real drift, but this is the data changes and the decision boundary may change. The concept models 2, 3, and 4. But what is a virtual drift? So virtual drift is a kind of thing that the data changes, the data decision boundary changes, but the model decision boundary is not changing. So that remains constant. So probability of X changes, but Y given X is not changing. So there is no drift. Only the data behavior has changed. So there could be like some things like the data decision boundary of one of the features is increasing space compared to the other one. And how this drifts can be, it could be abrupt, very sudden, or it can be gradual, like slowly happening. It could be seasonal or reoccurring, similar to time series patterns, as we can identify some patterns. Or it can be incremental in terms of slowly changing. It's giving a signal, oh, I'm going to change. And then when we identify the spike and the decay, we know that the behaviors are changing, and either it is following some random pattern or actual some definite patterns. We know there is certain things are going wrong in the input data stream or in the pipeline. And what would cause the changes? So we are taking an example of a pandemic. But it is not limited to pandemic. Some adversarial activities, some attacker is attacking the machine learning models, or the speed of learning and the output is not matching. The data is coming at a tremendous speed, but we are not adapting our model. It is training and it is running for a long time, and it is not checking the results. There is no monitoring system. There could be some external factors, environmental factors. There could be a cost due to the mistakes, like the penalties due to accuracies, that we are not classifying the data as a true labels. Or that is also the term called classification, regression, prediction, or accuracy, precision, recall. All this contributes to the drifting of the model. And if we talk about examples that we have seen, we can see the same pattern of gradual reoccurring sudden and spike in a ARIMA model using Sydney Ferry data, where the drift has been noticed after January 2020, most to February, March, April data. And in Australia, New South Wales ferry tap on tap off data, because people are not moving, people are not using the ferry. And it is very easy to capture drifts when we look at more historic data. So you see in the footfall, if you compare the footfall of different cities in US and Europe, France, Greece, Paris, Greece, Athens, Milan, you see there's a dip. There's a significant change in footfall, where in cafes, restaurants, bars, malls, shopping malls. And the drift is when the current machine learning model falls below a baseline. How do we capture that percentage of baseline? There are mechanisms. Let's go into that. So how do we catch those drifts, and what are the strategies? So one of the things is to identify the time of the drift, when it is happening. So what are the change points? How do we detect the change points? It could be we have some algorithms in place. We'll talk about some of them. Or it could be through explainable AI. We have those Shapely line inbuilt, and that analyzes the feature continuously. So that can explain that why there's change happening, which feature is changing. So other than identification, we can resolve the data drift. We can use a weighing data mechanism, whether simple weighing or exponential. We can also use weighted ensembles, like we can attach more weights to more recent data, like last 1 hour data, last 1 week of data compared to the older ones. we can windowing the data. You can see here, it's a constant window versus it's an adaptive window. So when we do automatic retraining of the data, we have the MLOps pipeline, then we can have more adaptive window rather than having a fixed window. In the fixed window, you see here the data changes. So we have to create a new window, have to adapt the data to the new recent changes. While in the adaptive window, we have the window size may sliding down over the more recent data. So it's continuously adaptive, and it is triggered to adapt in terms of shrinking or expanding the windows. So this is one of kind of time series, and other mechanism of time series detection is using the Dickey-Fuller test, hypothesis testing. So if you see the data of this data is from automobiles collision for previous years compared to 2020, and 2020 has seen a significant dip. Why? Because automobiles are not moving in US due to lockdowns and business closures. And how do we identify that? So there is a mechanism, Dickey-Fuller hypothesis testing, where we have that hypothesis data is non-stationary against alternative hypothesis if we have that the data is stationary. So alternative hypothesis that the data is stationary, and when the alternative hypothesis is true, rather than when the p-value is less than 0.05, we can reject the null hypothesis and take the alternative hypothesis that there is no drift, the data is stationary. Why the p-value exceeds the threshold? Yes, it's not any stationary anymore. And if we associate that concept in terms of the pandemic, if you have looked at some of the data using deep LSTM-based deep AR estimators or anything, even ARIMA model, we see that the post-pandemic models are having higher p-values, 0.92 here. So that exhibits a significant drift compared to historic models, which have been trained even prior to pandemic, prior to 2021. So these are like even 2020, 2019 data. So there is no drift. And when the drift happens, we'll see that also the mean and the standard deviation shows a significant change. Apart from doing hypothesis testing, we can also look at some of the confidence intervals which are provided by some of the libraries like Facebook Prophet. It provides the flexibility to have interval width where we can specify the confidence. If we add a higher confidence, that gives us a higher edge boundary. So if you are putting 99% confidence, 90% confidence, so it gives a larger width for my prediction to be accurate. So I'm telling I'm 99% confident. So I'm telling that my prediction will be correct 99% time, and I give a valid range from the actual true values. Whereas where I decrease my prediction confidence 50%, I'm more closer to the actual true values. So with the Prophet library, you can import the Prophet library, set the confidence interval, fit your data frame, and predict the future. And you can also do certain seasonal or holiday effects, regressors, automatic change point detection, adjusting your trend flexibility, and specifying the location of change points. Now, some of these traditional machine learnings we have talked about, we see an advancement like reinforcement learning. What do we do? So it's more about learning from the environment. We can have a multi-agent reinforcement learning, where there will be a collection of models and unique concepts, like where we handle the Q table, the policy concepts. We put it into the Q table, and we have a concept called error signal, that is the EM, with one active model. And we constantly try to measure that error signal with each of the models. And on comparison, when we find that we are suspecting change point detection, we actively replace the model based on the threshold of the error. So the previous model has error value greater than the E-mean, the threshold value. So we do, if it is yes, we do the previous model reactivation. If not, if the error value is not greater than the E-mean, we do the new model activation. And this concept of multi-agent reinforcement learning is more dynamic at creating different policies, and that learns from the environment. It is finite with distinct dynamics, and it can detect many changes in concepts dynamically, which is not possible with single agent reinforcement learning. So we can go through in more details, like how do we can handle this. So there are different categories. Now we have seen different algorithms, so we can just quantify the data in different categories, like the drift detection strategy, offline, like threshold monitoring. We have talked about some of the periodic retraining with sliding window. We can have SML training with recent or weighing the more recent data and the historic data. While online learning, we can have neural networks with different coefficients and weights to update the models. While we can also have data stream or online algorithms in the big data pipeline through Apache Spark, Storm to increase the weight of the recent data. When we talk about data, there are different change point detection mechanisms as well as removing those factors, some change factors, like removing the seasonality trains by differentiation or decomposition. In terms of data, we can also look at how do we do with statistical measures like total variance, variation distance, scale divergence. How do we compare two different distributions, whether there is a drift or non-drift, case distance. And there are some advanced mechanisms which you would like to go through after this talk, like a drift detection mechanism, early drift detection mechanism, because the DDM doesn't work in some cases, like Page, Hinckley, CumSum, and these are mostly statistical. While if we talk about sliding window, we have paired learners. So one machine learning is learning with the old data and the recent one is running with the new data. So when they crisscross each other, it's so much that the new model exceeds the old model, the performance. So we replace the new model instead of the old model. We have, in terms of decision trees, the degrees of drift, time tree features. So we can have a naive-based classifier at the root of the tree, and this error of pruning the trees or reclassifying should decrease. If it is increasing, there is a drift. And we can do it, we can catch it, such kind of contextual drifts. So there is an example how you can do with the Page Hinckley method. So you need to install the SK multiflow. And once you import that, you import the Page Hinckley library from drift detection and keep on adding data streams. So if you have data streams, say 1,000 points, 2,000 points, keep on adding that. And this library allows you to detect the change. Same with Adwin. Import the library, add the data streams, and detect the change. Now, what are the best practices? We have talked about drifts. We have learned why drifts are important. So in terms, nothing goes complete without having the entire pipeline. So faster model lifecycle. So continuously our model are getting updated into when new data instances are received or when a new drift is detected. So in terms of model deployment, we have to be very much vigilant about the pipeline orchestration, scalability, and containerization. While model monitoring, we have talked about the model monitoring its health, monitoring the accuracy as well as sending alerts on time. Doing this lifecycle management, either A/B testing, model version management, how the metrics of the models are changing, when we do the model retraining. And this doesn't end. We have to maintain everything in terms of lineage. Apache Atlas, integrate with that. Have the audit systems and security built in with your system, MLOps pipeline. Have workflow consumption techniques, how the model is getting consumed in the workflow. So in other words, if we want to iterate or summarize, so it is automated data preparation and training followed by model deployment, real-time model and drift management, periodic drift management, and augmented remediation. We should have remediation techniques. DevOps and data scientists, everybody should be aware of that, how to do that. So if we talk about AWS, so that's if you can bring your own on-premise cloud architecture, you can use all those techniques. But if you're looking for, if you already have a solution you're using for AWS or Google Cloud or Azure, all they have all this management techniques. So when you use AWS SageMaker, you can initialize your model bias monitor that can monitor your model biases using a proper appropriate role and how long time it will run, along with where it will put your destination data files where there has been drifts, and you can schedule that. And when you schedule that, if you when you call it at the last instance that show me the violation, where are the changes or the drifts have happened, it will give you a list in terms of JSON that these are the features which have violated due to these reasons. That also it can give you. So you have the data quality checks, you have model quality checks, model explainability tools, you have model algorithms, new algorithms, the drift detector algorithms, you have mechanisms to check bias. Along with that, we should have a monitoring technique that can detect drift. You can build it on your own, or you can use the AWS model bias monitor. And when we talk about risk management, we think of it's not only the job of the technical people, but also business, that how do we identify model risk and maintain the repository of models that have been as risk as for doing audit and learning about their schema and distributions. like what have been the input requests, and that has caused the model to change, the distribution and quality of predictions. So this is not a job of business or technical alone. Hand in hand, we have to work together so that we have consistent model mitigation actions, alerts, so that we can plan for both short term and long term business goals are achieved. So, and for technical people, we have to build the dashboards, analytic dashboards with the right set of talent, so that these are all visible to the stakeholders. Stakeholders may not go deep into the technical studies. They can look at the dashboards and understand what use case that models have drifted. So let's take one example from COVID. We have time constraints. So if you see here with the banking and finance example, so we can see that the banking industry says that model performance is vastly impacted due to COVID, and the impact is huge. Its small impact is also there, big impact is also there, but it's the highest among the model performance. 35% of the banks have reported a negative impact on ML model performance. Rather than people have understood, they have to move to ML and data projects, technology. These are all less. Customer engagement is less. There's not a negative impact, not less, then there's not a significant negative impact. And how do we, when our model is not performing well and we know that there is something happening, so how do we look at this side from business? So what are survival techniques for risk segments of population? Why they are getting impacted? Model is not performing. Is there any impact on that they are not coming to the banks, or they are becoming defaulters? So how do we do the default and delinquency prediction? So there may be liquidity needs. What are the measures that we are taking from the bank to give them more liquidity? How do we build around payment resilience? How do we engage the clients in terms of change in payments, maturities, rates, or limits? And how do we adjust the regulatory capital and liquidity of those impacted segments? And last but not least, how do we adapt and support? What are the new channels that we conquer new customers and help them with more volatility? Now, seeing so many things like why we need drift detection, how the consumer behavior has changed, starting from MLOps pipeline and the different phases of MLOps pipeline. Looking at AWS, a simple example, some of the examples using SK Multiflow. So what's the end goal of it? So we see that due to COVID, there are many industries that have been positively impacted. There has been an upsurge in revenues. These have been communication, home entertainment, online education, and medical supplies. We've talked about all those, some of those. Well, there has been a negative impact in the travel and hospitality, international trade. So either of this, whether you are positively impacted or negatively impacted, the model has shown a drift significantly in terms of positive prediction or negative prediction. Is the boost, if this is positive, the revenue boost is too much. We have not anticipated. In Tesco, like there's have been 400 times increase in the number of hits that the customers, the DevOps were experiencing. So whatever it be, positive or negative, our goal as a data scientist or ML engineer is to build higher accuracy, better performing models in COVID world with constant change and innovation. Innovation, we have to build it, because in retail also, even if we see a revenue surge, revenue increase, we cannot stop. We have to integrate virtual reality. And virtual reality, we have to bring in machine learning. How do we handle those drifts? So a lot of things needs to be studied. How do we can incorporate reinforcement learning? And the mind and the confidence has to be built in for automation and to handle both short and long-term changes, so that the customers at the end of the day are satisfied and we can better target them. So first of all, it's closed like a cycle. So like identify the business risks, use cases, build an ML model, and then use active learning, tune the model parameters, MLOps and automation, deploy the models, and then scale and improve. So that's how a machine learning pipeline can function and help in COVID era. So these are appendix some of the data sets I have added, and some of the example of a reinforcement learning, how it can help in supply chain. So thank you. Now open to questions.
Thank you, Sharmistha. That was a wonderful presentation. I know we went a little bit over, so if anyone's switching to another session, please make sure that you fill out the poll in this session before doing so. But yeah, if anyone has any questions, we can field them now. You can just drop them in the chat. I know there's a lot of fun sessions get going on, so understandable.
Any questions?
Is there going to be a link for the material? I mean, you can feel free to say whatever's public, but just so you know, the talks are recorded as well, so you'll be able to receive that eventually.
Yeah, I put it in OneDrive. I'll share the link.
Great. Then from Faraz, how do you communicate drift to business stakeholders due to shock events like COVID versus general degradation?
Yeah, so the timelines has to be seen, right? So what are the external conditions that is impacted, causing the impact? So if it is not due to COVID, then is there other external factor that is causing the drift? Or it could be a simple change in the data. The customers are changing, their modes and tastes are changing due to some other factors. So we have to take all those things and see that whether it is COVID or non-COVID, and it is irrespective of what is the reason. We should have dashboards and we should communicate it to the stakeholders. I hope
another question here from Radhakrishnan. How is the drift calculated for different verticals like retail, banking, and insurance?
Yeah, so retail, I think that has shown the significant drift due to COVID. So you can have your threshold percentages and the impact in terms of business revenues. So you should have like business metrics that you quantifies the drift. So that you're predicting that a customer can be a defaulter versus he's not a defaulter due to some change in your banking rules that can cause a significant impact to your bank. Your revenue, you might not able to recover the loan. So that your threshold should be very hard. Whereas for a retail thing, if you are recommending some items to the customer because of change in COVID or not change in COVID, that is not causing you a significant boost in revenue or decrease in revenue. One customer, if some of the customers you are recommending something wrong, maybe not wrong, but not COVID related stuffs like medical equipments or masks. So you have to analyze what is the impact, what is the customer lifetime value, what value he brings, how much revenue you are expecting from him. So that has to be taken in and quantified in terms of your models, how your prediction and accuracy is drifting, what is your tolerance limit.
And then another question from Faraz. How has your stakeholders reacted to the shock from COVID?
Yeah, so we have made a lot of mistakes. Like we have all this drift detection mechanism in terms of all the industry verticals we can think of, supply chain or banking or retail. But we have done mistakes and we have learned from mistakes. Like we couldn't handle loads for like retail giants, which saw significant boost in the number of hits. So if the front end failed, back end system failed. So we learned from them from initially. So the machine learning model will come next. If we are not able to sustain the load, then the machine learning model, how it comes to machine learning model. So we are also we also learned a lot of things then from initial things. Then when things started to change.
Great, yeah. So looks like there are no more questions in the chat. I'll give it another couple seconds or so, but otherwise, yeah. Thank you for a great talk.
Thanks. Bye.